CPU architecture, this is something that we do need to reference. The first thing we need to know is x86 versus x64. Now, why 32-bit computers are called x86, I'll never know, other than the fact that the first machines were, the 80, 286, 386, 486, etc. But then they went on to just be called AMD Athlons and Pentiums and Pentium 2s, and they were still all 32-bit. Okay, so x86 means it's a 32-bit operating system. That means it can run 32-bit programs, which the vast majority of programs out there, at least up till about 10 years ago, were 32-bit programs. They could also run 16-bit programs in a backward compatibility mode. 64-bit processors became popular again, at this point, maybe 15 years ago. They started kind of really getting popular. Windows Server operating systems from 2012 and on only support 64-bit. The client operating systems still do support 32, but the vast majority of PCs today are 64-bit. 64-bit just means they can do double the work of 32-bit. They will operate at sometimes slower speeds, slower frequencies, but because it's 64-bit instead of 32, it's going to be much more high performing. Advanced RISC machine ARM type processors, that is actually a separate architecture from both 32-bit and 64. It's one that is sometimes found in tablets, like the early Surface machines from Microsoft, but a lot of those tablets they don't necessarily all use it now, but that's where you would see that type. The speed is going to be a difference. So we see a picture here. This is the Task Manager program, and it shows that this CPU is operating at a frequency of 3 gigahertz. Okay, now that's pretty standard these days. The whole overclocking idea is I'm going to go into the BIOS and I'm going to mess with the CPU multiplier and have this CPU run at a higher rate of speed. Personally, the amount of benefit that you get out of that is minimal, and the risk is exceptional because you could burn out your processor, your motherboard, and that's not going to be warranted for sure if you're overclocking. So I would personally stay away from that. So that's the speed. Then you also see the cores. Okay, now so go look over to the right of our image. We see socket 1. That just means it is a single CPU. So anytime you hear multi-socket, you're talking about you have multiple sockets and multiple physical CPUs on the motherboard. The vast majority of CPUs today are going to be multi-core. So we see there sockets 1, cores 2. That actually means it has 2 arithmetic logic units. It is running as 2 separate CPUs within the same chip. And to further validate that, it says it's operating at 2 logical processors. Multi-threading is common, that just a thread is a unit of execution. This has been around since the early Pentium days, where multi-threading or hyper-threading is sometimes what it was called, just allows the processor to do more than one unit of execution at the same time. And then we mentioned virtualization support with the motherboards. Okay, we can see that actually here has to be turned on in for the processor as well. Okay, so virtualization says disabled, but Hyper-V support says yes. In other words, it supports it, it's just turned off. And so you sometimes do need to go into the BIOS or UEFI setup in order to turn on that virtualization capability.